Okay, so we're going to tell whether the parallelograms are similar. So first what you're going to do is you're going to actually set it up into a proportion. So the first proportion you're going to set up is using this shape, which is 5/7. And if you go in this order from the top to the bottom, you're going to have to go in the same order, top to bottom, to the right, to the shape on the right-hand side. So then you have 3/4 on that one. And all you're going to do is you're going to cross multiply with the proportion and find out if they're proportional. So 5 times 4 is 20, and 7 times 3 is 21. And because those are not equal, that is not proportional. Okay, so for this problem, we are going to do the two figures are similar. Find the ratios of the red to blue of the perimeters and the areas. So the first thing you're going to do is actually set it up in a proportion using the red to the blue. So we're going to just set it up as 9/4. And we can change the colors so you can see where they're coming from. And that is the perimeter. So that's all you do for perimeter. You just set it up into a fraction. And then for ratio, or for areas, you're actually going to square that. So if we had 9 and then 4, and we're going to square these, squaring, remember, means that you are multiplying it by itself 2 times. So 9 times 9 is 81, and 4 times 4 is 16, and that is the answer for the areas. And so this problem is actually really easy for all of the problems that you have to do for these. That is how you find the perimeter, and this one is how you find the areas. Okay, so for scale factor, you're going to do this problem. Your dad has a Corvette in the garage. You want to make a model of it. If your dad's Corvette is 15 feet long, how many inches would your model be using the scale factor 1 to 12? So the first thing you're going to do is you're going to make that 1 to 12 into a fraction, and you're going to set it up as a proportion. So 1 to 12, 1 being the smaller one, and your model is going to be smaller than your Corvette. So that's what you're looking for, which is the top, because we're going to go in the same order, small to large, going small to large down that way. And so we're going to do small to large going that way. So the answer, or the other number that we have, is 15 feet. So we're going to put that on the bottom. And then you're going to cross multiply. So you have 1 times 15, and then 12 times x. So let's write that down below, and 12x. And then 1 times 15 is 15. And then we're going to divide by 12 on both sides to get x by itself. And that is 1.25. And 1.25 is not the answer. 1.25 tells you how many feet that it is, but it's asking you how many inches. So you actually have to convert 1.25 into inches. So what you're going to do is you're going to multiply that by 12 because there are 12 inches in a foot. So you multiply that answer by 12 and you get 15. So it's 15 inches. I'll write that down here. So the answer is 15 inches to your dad's 15-foot long Corvette. And that's how you do scale factor. Set it up in a proportion, cross multiply, and then convert it into what they're asking for. Okay, so this comes from chapter 5.5, which is translating images on a coordinate plane. So this question is translate the triangle 4 units right and 3 units down. So you're going to start with each point and do them individually. So 4 units to the right, we'll start with J. 4 units to the right is 1, 2, 3, 4. And 3 units down, 1, 2, 3. So that's the new J. And then we're going to do K, which is 4 units to the right, 1, 2, 3, 4. And 3 units down, 1, 2, 3. So that is the new K. And then we have L, which is 4 units to the right, 1, 2, 3, 4. And 3 units down, 1, 2, 3. So that is the new L. And then you're going to draw your shape. And I have J on the inside, but it's okay. We'll just make J over here. So then it says, what are the new coordinates for the new image? So on the side, you're going to write J in parentheses. And J's new points are 2, 0. And then K's new points are 1, 2, 3, so 3, negative 3. And L's new points is 0, negative 2. And that's all you do for this problem. Okay, this one comes from 5.6, which is reflecting images either on the x-axis or the y-axis. So these are the 3 points that they gave us. A is 3, 2, so let's plot that. 3, 2 is right here. And then B is 4, 4, so that's right here. That's not right there. That's one up from there. 4, 4, which is right there. And then 1, 3, which is right here. So I'm going to write those points in. So I have A, B, and C, and then connect the points. Oh my goodness. Let's try that again. Yeah, well, you get the point. There we go. I'll just make it wider so you can't tell my mistakes, but that made it worse. Let's redo this. Okay. So 3, 2 is A, 4, 4 is B, and 1, 3 is C. There, that's better. Okay, so reflecting it in the x-axis, you actually don't even have to use a coordinate plane. You can just change all of your y values to negative. So if we do that first and then we test to see if we're right, let's try that first. There we go. If we actually change all of the y values for each one into negative, A would now be 3, negative 2. But that's the, yes. And then B would be 4, negative 4. And C would be 1, negative 3. Okay, sorry about the bell ringing. That was the other class leaving. So we have find the coordinates after reflecting in the x-axis. So we've plotted our figure, but then we're reflecting in the x-axis. And like I said, for the x-axis, you just change all of the y values to negative, or if they already are negative, you change them to positive. So you're just changing the sign in the front. So if we were actually to check our work, we can do it another one. We'll do it over the x-axis, which is this one right here. And we're going to reflect it over that. So it's going to be the same distance for A. It's going to be 2 away from the x-axis. So that means down here, A is now going to be there. And for B, B is going to be 1, 2, 3, 4 away. So down here at the bottom is going to be 1, 2, 3, 4 away, which is down here. And then C is going to be 3 away on the same line right here. So if we were to name these again, before we draw them, we have our new reflected shape down here. And if we were to check to see what the points are, we have A is 1, 2, 3, negative 2. And if you check over in the red, over here, changing the y to a negative is so far correct. And then we have B would be 4, negative 4. And again, if we were to check, yep, 4, negative 4. And C is 1, negative 3. And if you look here, 1, negative 3. So either way will work, whatever way is more efficient for you. For me, it would be just changing the sign in the middle, or in the front of the y values for all your points, instead of having to plot my points and draw it and then flip it and everything else. So that is how you do a reflection in the x-axis. Okay, so now we're actually going to reflect in the y-axis. So this is still the same as the x-axis question, but I want you to see the difference between reflecting the red to the x-axis, which is the blue, and now we're going to make it green so you can see how when you reflect it over the y-axis. So this is your x, and this is y up here. So if we're reflecting it in the y-axis, like I said before, we just are going to change all of the x values in the original coordinate pairs into negative for this one. So A would be negative 3, positive 2. B would be negative 4, positive 4. That comma's not even where it's supposed to be. Neither's that. No. Gotta make it interesting, Mrs. Glenn. All right, there we go. And C would be negative 1, comma 3. And all I'm doing is changing all the values of x into negative, because that is what we're doing. We're reflecting over the y-axis, so we do the opposite letter, which is x. So we're changing all the x values into negative. So let's see if that ends up being the right answer. So we have our C. If we are reflecting in the y-axis, it's going to be 1 away from the y, which is right here. And that is C. And then B would be 1, 2, 3, 4, 5 away, 1, 2, 3, 4. No, sorry, 1, 2, 3, 4 away. 1, 2, 3, 4 away on that same line, and that's B. And then A would be 3 away over here. Oops, not over there, over here. And that is your new triangle on that side. So let's check the coordinates to see if we are actually right with our changing the x values into negative. So we have, let's change it to a different color. We'll do yellow. So A in our reflected green shape is -3, +2. And does that match the green? Yes, it does. And B is -4, +4. And that matches that one. And C is -1, +3. And that matches that one. So like I said before, you can do either one, whichever one is easier for you to do, either plotting the points or just changing the sign in the front. And let's go on to the next one. Okay, this chapter is doing rotation, which is 5.7. So we are going to rotate the figure 270 degrees counterclockwise about the origin. And about the origin just means around the origin. So 270 degrees counterclockwise would mean we're going backwards from the clock, so we're going to go that way. And 270 is 3 90-degree turns, because 3 times 90 is 270. So if we are going to do point by point, if we actually name this A, B, and C, let's look at A first. So A right now is 1 away from this axis line. So if we went 90-degree turn down to the next one, it is 1, 2, 3, 4 up, but it's going to be on this line 4 up. So 1, 2, 3, 4, now A is going to be here. That's only a 90-degree counterclockwise turn. We have to go 270. So that's 90 degrees, and this would be 180, and then this one would be 270. So let me make sure I counted right. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Yes. All right, so this is our new A. And then if we were to do B, B is on that same line, but it is 1, 2, 3, 4 away. So 1, 2, 3, 4 away would be B here, and then 4 away for B at a 180-degree turn counterclockwise would be there, and 270-degree turn for B would be here. And then we only have one left, and that is C, and C is 2 away from this line on the 2 and 2, 2. So if we did 2, 2 over here, it would be 90 degrees there, and then 180, and then 270. So when you connect that, we'll make it a different color. We have the triangle at a 270-degree turn would now be located in the quadrant 4. This is quadrant 1, this is 2, this is 3, this is 4. And they write them in Roman numerals, which is I, and then 2 I's, and then 3's, and then an I and a V. So this is actually in quadrant 4. So that is how you do a rotation about the origin. Okay, so this is a tutorial about chapter 5 in your textbook, and this gives you an example of every single lesson within the chapter. You may rewind it, pause it, replay it as many times as you need to be able to figure out how to do each problem. All right, I will see you in the next video. Bye.